Okay, let's take a look at equivalent fractions here. So I have three fractions written out, 8/12, 4/6, and 2/3, and I'm going to color in a representation of 8/12. So here I've broken up, or I've got 12 squares together, so each square is 1/12. So 8 of them would be, so here we go, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8/12 right there. Okay. Now I've broken the same area into sixths, right? So my denominator is 6. It is telling me what I'm talking about, and the 4 is my numerator. It's telling me how many, so I need 4 sixths. So I'm going to take 1, 2, 3, 4. 4 sixths. Okay, cool. And then 2/3. So I'm going to, once again, my denominator says break it into 3, and my numerator says I need 2 of them. So 1 and 2. And what you'll notice is, of course, that the area that we've colored in for each is exactly the same, because these fractions are equivalent. They are actually the same number. So how do we figure that out? Well, one thing that we can do is reduce the fractions down to lowest terms. You'll notice that the two numbers here that we have, there is no number that goes into both 2 and 3. So let's take a look at 8 and 12. Is there a number that goes into both 8 and 12? Well, 2 does. So we can then say, okay, 2 goes into 8, so I could divide this by 2, and I could divide 12 by 2. And this is a thing that we're always allowed to do with fractions. You can divide your numerator and your denominator by the same number, and you will get, in this case, 4 sixths. And if you divide by the same number, the resulting fraction that you get will be an equivalent fraction. You can also multiply by the same number to get an equivalent fraction. So I could go the other way. 4 times 2 is 8, and 6 times 2 is 12, and I will get an equivalent fraction. Though most of the time, if we're looking to get into lowest terms, we're going to be dividing. Okay. Once again, though, I could divide by 2 again. Divide by 2, divide by 2. And that will get me to 2/3. Now, can I do that anymore? Well, I can't divide 3 by 2. 2 doesn't go in evenly into 3, right? It will get me 1.5, which isn't a whole number, and we're not interested in decimal numbers yet. Haven't got there. So there we go. So 2/3, that's as far as we can go. So this is lowest terms, and that's how you want to answer your questions when you answer with a fraction. You want your fractions in lowest terms. Okay, let's take a look at another example here. All right, so we have 6/12. So let's illustrate 6/12 now. Okay, so once again, I'm talking about twelfths. So each square in this box is a 12th because there are 12 squares. So if I color in 6 of them, that gives me 6/12. 3/6, okay, that's the same idea as before, but rather than taking 4 of them, I'm only going to take 3, so there we go, that's 3/6. And 1/2, well, that's just one of the 2 boxes here. So there we go, and you'll see, once again, the area is exactly the same for all 3, because they're equivalent fractions. And let's take a look. What goes into both 6 and 12? Well, 6 actually goes into both 6 and 12, but let's take an intermediate step for a moment, just so that we can connect them all. 6 divided by 2, and then 12 divided by 2 gets me 3/6. Okay, now, can I divide that by 2 again? No, but I could divide it by a different number. I could divide both by, say, 3. In this case, right? 3 divided by 3 is 1, and 6 divided by 3 is 2. And there you have it, okay? All right, so that is the introduction to equivalent fractions and lowest terms. Let's kick it up a notch and see how we can get from big numbers down to smaller numbers really quickly using prime factorization. Okay, so here we go. We're going to now reduce this fraction to lowest terms. Okay, so 126 and 525. Is there any obvious factors that go into both? Does it have any common factors? Not common multiples, but common factors. What goes into both of these numbers? Well, okay, does 2 go into both? No, certainly not, because the 525 is an odd number. 2 doesn't go into any odd numbers. So we could then try 3. Does 3 go into either? Well, I know it goes into 126 because I already did the factorization before, right? And we remembered that 3 goes into it. But we can also check by adding the digits and seeing if 3 is a factor of the sum of the digits. And this only works for 3, by the way. It works for 3, and it also works for 9, but doesn't work for any of the other numbers. So this trick only works for 3. If I add the digits of 126, I get 9, which is a multiple of 3, so therefore 3 goes into 126. I can add the digits of 525 and get 12, which if I add the digits of that, I get 3, which is of course a factor of 3. A multiple of 3. It's also a factor of 3, but it's a multiple of 3 is what I care about, which means that 525 was a multiple of 3. So that means that 3 goes into both of these. Okay, so I could just divide each of them by 3. And when I do that, what I would get is 126 divided by 3 is 42. And 525 divided by 3 is 175. Which is all well and good, but now that we've gotten to this point, it isn't clear whether we're done or not, okay? And in fact, we're not. But it isn't so easy to tell. So perhaps a better thing to do would be to get the prime factorization of both of these numbers and write those out. So I know from the work that I've already done, you can just rewind if you like to see that 126 is 2 times 3 times 3 times 7. Now I don't know off the top of my head what the prime factorization of 525 is, but so let's figure that out. 525, I can say, well, I've already did the dividing by 3, so I know that it's 3, which is a prime factor, times 175. Okay, and 175, well, I know that that's 5 times 35. Why? Because I already did that number, but yeah, so it's 5 times 35, and 35 is 5 times 7, which are both prime numbers. So 525 is equal to 3 times 5 times 5 times 7. So what this fraction is 2 times 3 times 3 times 7 over 3 times 5 times 5 times 7. Okay, and now all we need to do is do what's called cancellation. If there is a common factor in both the numerator and the denominator, it can be canceled. We can divide numerator and denominator by both. So what we can look and see is there is a 3 in my denominator, and there are 2 3's in the numerator, but I can only cancel one of them because I'm canceling only one from the denominator. So I can cancel out a 3, right, which is the same as dividing by 3, right? That's what we're doing here. And then I can also cancel out a 7. So we've canceled out a 3, we've canceled out a 7, and what that leaves me with is 2 times 3 over 5 times 5. 2 times 3 is 6, and 5 times 5 is 25. And if we look back up here at the work that we did, we had 42 over 175. Okay, and I could divide this by 7, divide the denominator by 7, numerator and denominator both by 7, gets me 6/25. So it is possible to do it step by step, and if that's what you want to do, more power to you. But I do recommend prime factorization because it does speed things up quite a bit when you don't know what's going on. If you're not able to recognize factors of 7 off the top of your head, and I certainly am not, then prime factorization makes it an easier go. All right, so that is how to reduce a fraction down to lowest terms. Notice this is lowest terms, right? And I can tell because I've got the prime factorization right here. Are there any factors that are in both 6 and 25? Well, the prime factors of 6 are 2 and 3. The prime factorization of 5 is 5 times 5. There is no overlap at all. There's no more cancellations that can happen. So 6 over 25 is in fact the lowest terms. So this is lowest. Terms. There we go. Okay, and that is our goal. Excellent. Okay, so we have just covered equivalent fractions and lowest terms, okay, which is great. And now on to improper fractions and mixed terms. So let's do that.